Hello everyone and welcome to PA Academy. So in this video series we are going to be looking at nodal analysis. So nodal analysis is one of the ways we use to analyze circuits. We have the mesh analysis, super mesh, nodal, thevenin and the likes. But this video is going to focus on nodal analysis. And in doing that, there are different examples I'm going to be using to explain that in this video series. So at the end of this video, I'm very sure you'll be able to solve just any question that has to do with nodal analysis, either nodal analysis or super node, whatever it is. I believe at the end of this video series, you'll be able to do that. So just make sure you watch it to the end. And if at any point in time you have any question, you can leave them in the comment section below and I'll personally attend to it. So if that interests you and you are yet to subscribe to this channel, PA Academy, please click on that subscribe button. It's absolutely free to subscribe to this channel. Alright, so if you have done that, thank you very much, and let me know in the comment section below if you have subscribed to PA Academy. Alright, so now let's get into this video, nodal analysis. Now from the word nodal analysis, or nodal itself, that means from the word node. And if you are familiar with circuit, you have heard the word node, it simply means what? A point where three or more elements, their point of they meet, or where they have been connected. For example, this point here is a node. Why? Because we are having these three elements. This is where their point of connection between these three elements. Let's just say their meeting point is here. This is also a node, because it's connecting 1, 2, 3. It's connecting these 3 points. So when we talk about nodal analysis, we pay attention to the node. And one of the things that we also use to solve them is the Kirchhoff current law. So I'm going to put you through all the steps you are going to use to solve it. So this is one of the circuits I'm going to be using. You can see this is a very simple and basic kind of circuit. So I'm going to be using this to analyze, explain nodal analysis, and you are going to be looking at more examples in the course of this video. Alright, so now that we've have a little understanding of what nodal analysis is, I want to use this circuit to explain. It says find the value of the nodal voltage. So what it means is that we should find the value of the voltage at those points. And don't forget, the method we are going to be using is nodal analysis. One of the things about some of these circuits is that there are other methods or other ways of analysis that you can use to solve them. But once a question is more specific about the method you should use, then you have to just follow it. Alright, so first thing you have to do when you are dealing with nodal analysis is for you to identify how many nodes you have in that particular circuit. Now, using this as an example, we have 2 nodes. This is a node here, and this is also a node. So once it is nodal analysis and you have been able to identify all those nodes, you are going to pick one as your reference node. Exactly. So one as your reference node. So this is one I'm going to pick in as my reference node. Now, that reference node, you take the voltage at that point to be 0. Exactly. So that is the at this point, which is the reference node, you take the voltage here to be 0. Now, not just for this, but every other thing, you are going to sit down and solve more questions. Now let's continue. So once you have done that, you have identified the node, you have picked your reference point, and you have identified it to be 0. The next thing is to pick your current direction. Exactly. You pick your current direction. For example, in this circuit, you already have a current source like this and with their direction. So we can decide to follow the direction that they have. So let's say from this node down here to this other node, let's follow this direction. Let's say it's going in this direction. Exactly. And why for also on this branch, on this part of it. So let's say let's use this direction like this. So that means current is flowing, let's say, from this node straight to this node, and let's say from this node current is flowing like this. And why for the one at the middle, let's just pick it downward like this. Exactly. So you can pick, random direction. So once that is done with this, now what it simply means that on this node V, we have so that means we have one incoming. So this one is incoming, and these two, they are what? They are outgoing. Their outgoing current. So you have to note that. Alright, so now that you've picked it and then you've picked your direction, the next thing is for us is to apply Kirchhoff current law to the nodes. So right here we have just one node. So we are going to apply Kirchhoff current law to this particular node. Don't forget, we are looking for the voltage at this particular node. So what do? So I'm going to analyze this circuit like this. Then we'll say, okay, apply Kirchhoff current law to node V. And in applying Kirchhoff current law, what does it mean? So that means we are going to calculate all the current that is entering the node equals to the current that is leaving that particular node. And now we are looking at node V. Exactly. So The current that is entering is just the one from the reference node. You take it like this, since it is this the direction, like this. Exactly. So the only current that is entering is this 2 amperes current. So we note that that is 2. And then the outgoing current, so there are 2 currents leaving this node, that is from here and the one like this. So let me start from here. So the one moving like this is 8 amperes, that is 8 amperes plus. Now for me to get the current here, you can see we don't have an exact value for the current that is flowing here, unlike here where we have that, okay, the current here is 8 amperes, the current here is 2 amperes. But from the from Ohm's law, where we have V is equals to IR, then we know that if you have to get current, that means I is equals to what? V over R. So what that means is that for us to get the current here, we are going to be having the voltage that is from here, between here and here. Don't forget the voltage here at this point is V. We don't know the exact voltage here, that's why it's V. But these are the reference points here, where we've taken as our reference point here is 0. So we are going to be having, since, and it is in this direction, you also have to pay attention to it. Since we have taken it to be this direction like this, so where it is starting from to where it is actually going, let me use that word so that you can understand. So that will be V minus 0 divided by what? The resistance, that's V over R. So now we've gotten the V to be V minus 0 because this is 0. So I intentionally had it here, some might decide to skip it, divided by 10. Are we following? So with that we are going to be having 2 is equals to 8 plus 2 equals to 8 plus V divided by 10. So this is just the normal math. So this will be 2 minus 8 equals to V over 10. And with that we are going to be having minus 6 is equals to V divided by 10. So once you cross multiply, you are going to be having your V is equals to what? Minus 60 volts. And this is the answer. So that means the voltage here, you know that voltage at this point V is minus 60. Now this is a very simple explanation on nodal analysis, and as we go on in this class, in this lesson, we are going to be seeing more examples on the concept of nodal analysis. I hope this example is clear. So in example 2, we are going to be looking at something different, something more different than this. So this is just the basic concept of nodal analysis. Alright, so this is example 2. Let's analyze this circuit. The question is the same thing. It says find the nodal voltage, but this is another different circuit. Now this is find the nodal voltage V. This is the point where this is this node. We are asked to look for the voltage at this particular node. So we represent it with the V because we don't know the value. So like I said earlier, if you are solving nodal analysis, one of the first things you do is to identify how many nodes do you have in that particular circuit. In this particular circuit also we have 2. So we have this and we also have this. And I said once you identify the 2 nodes, you always pick one as your reference node. So I'm picking this as the reference node. So and at that reference node, the voltage at that point is always is 0. So you take it to be what? To be 0. Now once that is done, you pick your current direction for each of these branches. So from the reference node down to this point V is one branch. From this V to the reference node is one branch, and here is also another branch. So you pick a random direction that best suits you. You can decide to say, okay, for this particular one, the current is going in this direction. That means from here it's going like this. You know, it is left to you. So you can also pick just any random direction. So this is what I'm going to be using. So what this means is that at this particular node V, so if I'm to indicate it here, that means there is a current like this. Okay, so this is it. So what it means is that we have 2 incoming currents and 1 outgoing current. So this here, let me call it I1, I2, and this is I3. So what it means is that I1 and I2 are what? Are incoming. They are incoming current entering into this node, while I3 is the what? Is the outgoing. Is the outgoing current. And if you remember Kirchhoff current law, that means what? You are going to be having what? I1 plus I2 equals to what? I3. So that's just the concept of nodal analysis. After you have fulfilled all those things, you identify the nodes, you pick your reference point, then you pick the direction of current. Exactly. So don't worry, just follow. In this example now, we are dealing with just a circuit with 2 mesh. In more examples, you are going to be looking at the one with 3, 4, and the likes. So I'm just trying to take it from the basics so that we can all be on the same page. Alright, so let's continue. So let me just All right, so now we've been able to pick direction of current. So the next thing we have to do is to apply KVL to this particular node. So let's do that. So if you have apply, did I just say KVL? No, KCL, Kirchhoff current law, not current voltage law. KCL to node V. To node V, KCL, just in case I mentioned KVL earlier. Just know that it should be KCL, Kirchhoff current law. So if you have to apply Kirchhoff current law to this particular node, so pick it from here. Exactly. So this is what you do. Pay attention to this. Since we've taken the direction to be like this, that means the current is coming like this. So what you do is you calculate for the current in this node that is entering here, all the incoming current, you put it in one side equals to the outgoing current. So for this particular one now, this particular branch, since it's starting from 0, that should be 0. The voltage at this point is 0. Exactly. And it's going to this point V. That will be 0. And then you have it as minus V. Exactly. This is how I like to do it, just to avoid any kind of mistake. So based on the direction, you pick it from where it is starting from, which is 0, subtract from the next node, the value you're having on the next node, which is V. Then after that, I consider whatever other voltage that is along the line. So if you are coming like this, we also have a 10 volts here, which is from minus to plus. That will be plus 10. Then divided by 2, which is a resistor. What we are having here is current. Whatever we are having here is giving us the current that is flowing through this particular branch. Remember, let me write it here again. Ohm's law from V is equals to IR. So that means our I, if I is something of the formula, we are going to be having V over R. So what we are having here is current, because if you look at the value at the top, they are all voltage. This is 0, this is V, is also a voltage, this is 10, and this is also a voltage. Why this 2 is a resistance, which is 2, which is R rather. This 2 is resistance, which is R. So what we are having here is V over R, which is the current at this particular point. That's why I said apply KVL to node V. Alright, so this is for this one that is going in. So then plus, we look at which other one again is also going into point V. On this side also, if you look here, based on direction we picked, so it's just continue like this. The fact that we wrote it here, it's continue like this. Exactly, so it's like this, because this is the reference. Exactly. Alright, so on this part also, so that's why we have plus. So from the reference, that will be 0. I just omit whatever is at the middle, I go straight to the end. 0 minus V. Then I consider whatever voltage source I'm having in between. So this is minus to plus, that will be plus 7. Then divided by whatever value resistance you're having in between. So that will be divided by 3. Then you have equals to. Now the reason we're having equals to, these are the only two current that is going into V. Now on this particular branch, we have a current that is moving outside of it. So for us to calculate that, so from where, since it is coming from V to the reference, that is how do we what? V minus 0. There is no other voltage source in between, so we are just going to be having V minus 0 divided by 1. I hope this is clear. Now let me also make something clear here. Here we are having V minus 0, unlike all these places where we are having 0 minus V. Let me explain this again. Here there is V minus 0. We are taking that the current is coming from here, from this particular node, straight to the reference node, based on this direction that we picked. Exactly. Why on this particular branch, we are taking the direction to be like this. So that means the current is coming from this reference like this. So it is where it is coming from is what the first thing you write, then minus where it is going. The node where it is coming out from minus the node where it is going. I hope that makes sense. So now let me just make this much more neater. So this that we are having here, we can rewrite it as 10 minus V divided by 2. Naturally, I can just go ahead and write this, but I want to make sure that I carry everyone along. So this is then plus, this will be 7 minus V divided by 3 equals to V. You can just say V over 1. Alright, so at this point now, what we just do is just a basic board math here, or basic math. So here the LCM here is 6. Then 6 divided by 2, that's 3. 3 times 10, that will be 30 minus 3V. And then 6 divided by 3, that's 2. 7 times 2, 14. That will be plus 14 minus 2v equals to v over 1. So once we cross multiply there, we are going to be having 30 minus 3v plus 14 minus 2v equals to 6v. Alright, so let's just rearrange this. So we are going to be having minus 3v minus 2v. If this should come to the other side of the equals to sign, because it becomes minus 6v equals to. So let's take the 30 and the 14. 30 plus 14, that's 44. So if you take it to the other side, it becomes minus 44. So it becomes minus 44. So this is minus 3, minus 2, and minus 6. So that will give us minus 11. So we are going to be having minus 11v equals to minus 44. So here we can divide both sides by minus 11. So that means our v will be minus 44 over minus 11. And that will give us 4. So that means our v is 4 volts. And don't forget your units. Always include your units. So what it means is that the voltage at this point is 4. The voltage at this point is 4. So this is how to solve this. If this question still look very basic under nodal analysis, but nodal analysis is not difficult anyway. So in the next example, we are going to be looking at another circuit with 3 meshes. This is just 1, 2. We are going to be looking at another one with 3 meshes. So if you find value in this, please give it a thumbs up. So that other examples will be coming out in the next in another video. So please make sure you subscribe to this channel and then you give it a thumbs up. So that video will be coming up immediately after this under nodal analysis. Thank you very much.